The system we are going to describe in this video has been designed and will be used for radiological characterization of conditioned waste stored in 400-liter steel drums. It will be installed in a dedicated shielded room and will measure one drum at a time. Drums will be transported to the measurement room by remotely operated cart on rails. The scope of measurement is similar to our conveyor system for standard 200-liter drums, which means spectrometric characterization of the drum content using high-purity germanium, gamma radiation dose rate measurement at 1 meter from top and side of the drum, scanning 100% of the drum surface to find maximum dose rate at 10 mm distance, and surface contamination check on 5 predefined areas. One of the key issues to be addressed in the design of this system was random position of individual drums when they arrive to measurement position. The tolerance is around 15 to 20 centimeters in both horizontal axes. Before drum is lifted from the cart, its relative position is therefore measured by displacement analog sensors. Correct position of the lifting mechanism is then calculated and the frame is moved in both horizontal directions by servo motors. Clamping and lifting sequence is activated afterwards. Rotation of the drum starts and radiation spectra is acquired to characterize radioactive content inside the drum. As the required range of activity level was extremely high in this case, which means equivalent dose rate from 1 microsievert to 1 sievert per hour, fully automatic collimator has been designed with 4 sizes of opening. Special X-shaped tungsten components were used to reach required mechanical precision and attenuation level. In parallel to spectrum acquisition, gamma dose rate at a distance of 1 meter from top and side of the drum is measured for different angle sections. Spectrum is afterwards analyzed by GAMWin libraries embedded into GAMS Control Windows-based software, both software packages being developed by NUVIA software team. Also, at the same time, a robot automatically takes a tool with on-purpose designed wide-range gamma probe and starts scanning of the drum. 100% of the surface is scanned from a distance of 10 mm to find maximum dose rate near surface. Acceptable limits are preset within control software as well as many other parameters. Gap between the gamma probe and the drum is dynamically adjusted based on reading from laser distance sensor to compensate for any mechanical imperfection of the currently measured drum. Once the scanning is finished, robot exchanges tool to be able to pick up so-called frotty, which is basically circular piece of textile fabric stick to rectangular wax paper. Proper fixing of frotty to robot is checked by camera before and after wiping. Robot then wipes predefined area of each section of the drum. 5 sections are defined. To keep the contact area between frotty and the drum constant, robot is equipped with a force feedback system. For each section, new frotty is picked up from a tray. After wiping, frotty is automatically measured by lead-shielded alpha-beta contamination monitor. Used frotties are thrown to dedicated trash bin. In case of high radiation background level reported by contamination monitor, frotties are not measured immediately after wiping, but temporarily placed in a dedicated nests by robot. After evacuation of the drum from room, frotties are automatically measured one by one to finish the whole process fully. To maintain a consistent system performance over time, fully automated QA check procedure is implemented for all measurement devices. Exchangeable tools with alpha, beta and gamma reference sources are brought close to individual detectors by robot in predefined intervals and the response is compared with expected values. One drum is being measured around 60 minutes. As we deal here with highly active content in the drum, in case of a failure of automatic control systems, any servo motor and so on, we face the problem to return the drum safely to a cart and evacuate it from the room before any technicians can come to solve the problem. This issue has been addressed by implementing an emergency release system, which is based on standalone relay logic backup motors and safety clutches.